Good morning, my dear students. Welcome to online classes. In last class, we are discussed regarding to the displacement current to density, the frequency at which the displacement current and displacement current to densities are equal, and some of the problems on JC, that means displacement current density and conductional current density JC, as well as frequency at which JC and JD are equal. Now we are going for the very important concept with respect to the examination point of view, that is Maxwell's equations for time varying fields. Maxwell's equations for time varying fields. For time varying fields. So, in the third unit, we are discussed Maxwell's equations for static magnetic fields. Maxwell's equations for static magnetic fields. That is static electromagnetic fields. Maxwell's equation for static electromagnetic fields. What are those means? See here, the first equation is divergence of d bar is equal to rho v, which is a point form. And coming to the integral form, closed surface integral of d bar dot ds bar is equal to volume integral of rho v dv, which is the first Maxwell's equation. It is from Gauss law in electrostatics. Second is from curl of E bar is equal to 0 in point form, and in integral form closed line integral of E bar dot dl bar is equal to 0. It is from conservative fields or conservative electric fields. And the third equation is curl of H bar is equal to J bar in point form, and in different integral form closed line integral of H bar dot dl bar, that is equal to I enclosed. This I enclosed can be write closed surface integral of J bar dot ds bar. So, which is from Ampere's circuit law in point form and integral form. So, finally, divergence of B bar is equal to 0, and in integral form closed surface integral of B bar dot ds bar is equal to 0. So that means these are the Maxwell's equation in point form and integral form for static fields or static electromagnetic fields. So for this concept we have two questions. One is for 2 marks and another one is for direct 10 marks. For 2 marks you will directly given these equation in table form, in point form as well as integral form. But in 10 marks, along with this table, you can given the word statement for each Maxwell's equation. So now we will see. So this is the Maxwell's equations for static electromagnetic fields. Now in the fifth unit, the thing is Maxwell's equations for time varying fields. So then first we will discuss in point form. So in the point form, the Maxwell's equation is, first to Maxwell's equation is divergence of d bar is equal to rho v in point form or differential form. Point form or differential form. While coming to the integral form, closed surface integral of d bar dot ds bar is equal to volume integral of rho v dv, which is from Gauss law. Gauss law for time varying electric fields, which are derived from Gauss law in time varying electric fields also. So then next one is divergence of b bar is equal to 0 in point form, but in integral form closed surface integral of b bar dot ds bar is equal to 0, which is derived from Gauss law for magnetic fields, that means Gauss law for time varying magnetic fields. The next one is curl of h bar is equal to, in a time varying fields, the curl of h bar is equal to jc bar plus jd bar, because of for time varying fields the current flows through the medium or conductor, current flows through the medium is both the conductional current density plus displacement current density. So then here it is That's why curl of h bar is equal to jc bar plus jd bar. But in integral form, closed line integral of h bar dot dl bar is equal to closed surface integral of jc bar plus jd bar means dou d bar by dou t ds bar. So now the fourth equation is curl of e bar is equal to minus dou b bar by dou t, minus dou b bar by dou t, which is in point form or differential form. But in integral form, closed line integral of e bar dot dl bar is equal to minus closed surface integral of dou b bar by dou t into ds bar, which is from Faraday's laws of electromagnetic induction in time varying fields. That means these are the Maxwell's equations for time varying fields. Maxwell's equation for time varying fields in point form or differential form and in a integral form. In the next video, we are go for what statement for these Maxwell's equations in time varying fields.